go ahead and do the assignment on your own if you'd like to, but I don't think you need to do this assignment to really understand it. What is an odd function? Well, I'll draw an example of an odd function. Except the smartboard got stupid all of a sudden. So we'll wait for the smartboard to get back into its regular mode here for the light to stop blinking. YouTube Nation is in suspense, just waiting. There it is, boom. All right. Anybody know what kind of equation that is? If what's the parent function? What's the y equals what? Yeah, it's x cubed. Yeah, and that's actually called an odd function. Anybody want to guess why we call it odd? Oh, you see an odd exponent. Look at that. Then here's an even function. And that would be, say, y equals x squared. Anybody want to guess why we call it even? Yeah. So if you see even exponents, it's an even function. If you see odd exponents, it's odd. Now, here's the problem, okay? If you examine it, you can see that this function is symmetrical about the origin, meaning if you spin it 180 degrees, it makes the same shape. This is symmetrical about the line y, or about the y-axis. But we also know this. Y equals sine of x is also an odd function. And y equals cosine of x is an even function. Now, you're not real familiar with those graphs or what they look like. But the fact is we don't see an exponent on those. So what is the mathematical test that we do to show that something's odd or even? Here's what we do. We take the function and we plug in a value. We plug in negative x. And if, when we plug in negative x, it produces negative f of x, then we state that the function is odd. What that means is if I grab an x value, you can see that it produces a positive f of x value. But if I grab a negative x value, it produces the same f of x value, it just happens to be negative. See how those would correspond with one another in symmetry? That's what this statement is saying. For an even function, f of negative x produces just f of x. As you see, if you plug in an x value here, it produces an f of x value. If I grab a negative x value on the other side and plug that in, you can see I get the same f of x value. So it doesn't matter whether you plug in the value on the right or the left, it's going to produce the same height. That's what makes it even. So that's the definition of odd and even. So let's do two quick examples for this, and we'll get to the, kind of what we're going to do for our assignment today. It says determine if the functions are odd, even, or neither. So by looking at the exponents, do you think that letter A is odd, even, or neither? What do you think? Why would you say odd? Yeah, I got 3 and 1, right? So both exponents are odd, so this is an odd function. Let's show that it's odd. In order to show that, okay, so if you plug in negative x, that means we replace x with a negative x. So we take negative x and we cube it, minus 4 times negative x. Now, if you take negative x and cube it, will that produce a positive x or a negative x? It'll produce negative, so negative x cubed, and the minus 4 times negative x would be a plus 4x. Is that the same as what we started with? No, it's different by a factor of negative 1. So if we were to factor out that negative 1, we would get x cubed minus 4x. Now I'm going to make one last statement here. Notice I'm just going to write this as negative because I have a negative sign. And instead of writing x cubed minus 4x, what can I write instead of x cubed minus 4x? X cubed minus 4x is the same thing as f of x. So look at our line of logic here. Well, that kind of... You started with f of negative x, and you ended up with negative f of x. Isn't that nice? That's what we were trying to show. You just did a small proof. You proved that that function is odd. Good job. You should be so proud of yourself. Next one, do you think it's odd or even? Or neither? Even. If you look, 10x to the 0 power. Anything to the 0 power is 1. So that's why the x does not show up. And so you can see that 2 and 0 are both considered even. Let's show that it's even. We will plug in a negative x, and we get negative quantity, negative x squared, plus 10. Well, order of operations says that I need to square this first. A negative x squared will be x squared. Then I multiply it by negative 1, so I get negative x squared. Is that the same as what I started with? It is. In fact, it's the same as f of x. So our line of logic just stated that f of negative x is f of x, which is what we wanted to show for an even function. Last one, we're not going to show it, but I'm just going to ask you, do you think the last one is odd, even, or neither? Are you sure? Would you be willing to wager money on it? Dane is not. Josie is. Benda is. You want to wager some money that it is even or it is neither? Which one? You don't care because you got dollars like a crazy man, right? Maybe you're really, maybe you're an addict. Okay, all right. We'll have an intervention later on. Okay, so the fact is that this is even because you see the x to the 0 power again. If I changed it and it was just plus x, that would be plus x to the first power. There you see a mix of both even and odd that would create neither. Okay? Would you get a question like that on the ACT? Yeah, generally about every other ACT test I take has a question about odd or even functions. And so you got to remember the two things. Even is symmetrical about the y-axis. Odd is about the origin. And then the other thing you got to remember is just odd and even exponents. So if you can keep that in mind, you'll be good to go. Okay, so that wraps up that little piece. Now what I want you to draw is draw some of these functions in place. We're going to start with this parabola. It's going to be at this location of the vertex here is at 0, -3. And our real learning target of the day is not just to look at odd and even functions, but rather to write rules for functions that have been transformed. So we've done a lot of transformations where we've seen the rule and then we graph it. Well, now we're going to take the graph and we're going to write the rule. And this is to try to help build connections to help you remember it for a longer period of time. So I know that the parent function is x squared, but can somebody tell me the two transformations that occur with this example? Vertical flip and down 3. So both are vertical, so they're going to stay outside. And my result will be negative x squared, negative x squared minus 3. Now, there's actually many options that you could write for a rule. That's just the most common one that people do. There's many options for an answer here, okay? One great thing you can do when you're taking notes is I got to talk to the rest of the class about this, but let's admit, anybody ever get in a habit, and maybe it's this class, maybe it's not, ever get in a habit of you're just like taking notes in class and like you're just trying to get it all down. Like you don't really actually fully focus on what's happening. Josie, happens sometimes. For mine, it was psychology class in college. I would be trying to stay awake. I just be like, I just got to make sure I write everything down so then like later on I can look back at it, right? And it's such a bad practice, right? We understand why it happens. The reason why I give you guys these notes is so that you can look ahead of time and try to predict what's going to happen with the next problem. So that's one of the best ways that you can enhance your learning is to try to predict with the next problem. So as we do it, look ahead and see, well, how's this one going to be different? How's that one going to be different? So parent function, what do you think? X to the third. So any horizontal movement here? Yeah. So how am I going to show that horizontal movement then? Since it's horizontal, it will be on the inside, x plus 3, and we'll cube that thing. And then we do have a vertical flip, don't we? So we'll stick the negative on the outside. Okay. We look to the next one. Again, the parent function. Can you remember that parent function? Square root of x. Good. Heard somebody say that. So I got two transformations here. What are they? Up 2. So that's going to be on the outside because you just said vertical there. So we're going to go up 2. So plus 2. I know that. And what else? Yeah, x plus 3 because it's again to the left 3 units. Okay. I just heard Doyle say, Mr. Gans, step up your game. This is too easy, so thank you, Doyle. I will. I don't want to disappoint. Okay. All right. Don't call me out from now on. So let's look at number 4. So I have a vertical asymptote through 2, and I have a horizontal asymptote through 0. So I'll let you draw that into place. So vertical asymptote through 2 and horizontal asymptote through 0. Tough to think about this one, but anybody know what the parent function is? Okay, the fraction. So let's try to make the connection here. We'll make a connection. Is it 1 over x or is it 1 over x squared? Which one is it? Sam is right. It's x squared, but it's negative. Let's look at something we just learned today that can help you understand. Okay, they're in the same quadrants, side to side, right? If you think just here, odd and even, odd, they're in opposite quadrants. Even, they're in the same, right? It follows suit exactly with this situation as well. Since they're symmetrical like that about the y-axis, then you would have x squared. So this is going to be y equals, I've got that negative, I've got that x squared, but there is a horizontal shift as well, isn't there? So how do I account for that? X minus 2, that quantity squared, yeah. Now, suppose that you were to write it to the 4th power, I'd still give you credit. Suppose you write to the 6th power, I'd still give you credit. There's not much of a difference between 1 over x squared, 1 over x to the 4th, but there's a big difference between these two. Big difference there, okay? Ooh, can you think of the next one? Parent function? X to the 1/3 power, the cubed root. Yep, the cubed root. So you could write as x to the 1/3, or you could write as a cubed root of x. Okay, I think I do both on my answer key from time to time. Um, so I'm going to go y equals, and I'm going to put a negative because I do see that there's a vertical flip going on. What goes on the inside? X plus 3. Anything on the outside? Yeah, plus 2. So again, just remember, it was just a few days ago, you looked at these equations, you looked at these graphs, you're like, it would take a long time to figure out what those graphs are. Well, we're doing it in a matter of seconds. Okay, so just a few tricks of math can really teach that. This last one's hard. We got the square root of x going on. So we got y equals, I've got the square root of x. I know it's down 3, so I'm going to go minus 3. And I know it's right 6, so I want to do x minus 6. But I'm also thinking there's a vertical reflection here, or there's a horizontal reflection here, isn't there? So what do I have to do if there's a horizontal reflection? Good. So you have this as an option. Okay, heard what Luke said. He said we're going to do a 6 minus x. If you think of it like this as well, if you thought of the x minus 6 and then said, oh, I have to apply a negative to it, you would get the same thing, right? The idea is that when you plug in 6, you're going to get 0. That's the important piece. So the answer is 6 minus x. If you wrote the negative and then it was positive x minus 6, I would also give you credit for that. That's fine. So, any question there? Going once? Twice? 3 times. Very good. Nice job. Got half an hour. I'll